Hey class, this video is going to be on the final exam review. This video is going to go over the first 20 problems of the 40 problems that we have for our review packet. I've already given you the answers, but this video will be on the solutions on how to tackle every problem here. Alright, so I'm just going to begin. So number one, it says a right triangle is shown below. We have sides 5, 12, and x. And the question is what is the value of x? Okay, so looking at this, we have a right triangle. I want to find a missing side, so what we're going to use is the Pythagorean theorem. Alright, the Pythagorean theorem says that a squared plus b squared is that if you have a right triangle, a squared plus b squared is equal to c squared. Where c squared is our hypotenuse, and coincidentally, that is the side that we want to find. Okay, so looking at this, 5 and 12, those are our a and b. You can just write them in any orders, but for this I'm going to have that a is 5 and b is 12. Okay, I'll put that c is x. So straightforward, just simplifying here, 5 squared is 25 plus 12 squared, which is 144, equal to x squared. With this, we have to add the two numbers on the left hand side, and this gives us 169 equal to x squared. Alright, now the question told us to find what is x. I have x squared. How can I get rid of this square? The process here to get rid of or undo squares, the inverse of that is square roots. So I'm going to square root the right side, but since it's an equation, it has to do to both sides. Okay, so squares undo square roots. Right hand side, we're going to have x, which is what we want. The left hand side, we have the square root of 169. So I'm asking myself the question of what number multiplied with itself will give me 169. That number turns out to be 13, because 13 times 13, 169. So our answer for number one is A, it is 13. Alright, so Pythagorean theorem in this final exam is going to be hugely important that you can notice when to use it and be very careful in how to tackle this problem. Number two, a 15-foot ladder is placed against the wall. The bottom of the ladder is 5 feet from the wall to the nearest foot. How far up the wall does the ladder reach? So we're resting this ladder against the wall. Now for me, what would really help, it would be a tremendous benefit, is drawing a diagram. So here is my idea of a wall. Here is my ladder. And here is how far away it is. So it creates a right triangle. So our ladder is 15 feet tall, or lengthwise. It's 5 feet away from our wall, and we want to find what is this distance. When I lean that up, how far up the wall does it touch? Okay. Well, with this, we have a right triangle, and very similar to the first one, we want to use the Pythagorean theorem. So just to make sure that I'm very careful with this, I'm going to go ahead and write the Pythagorean theorem here. Now, with this, we have to note that our c is the number that is directly across from our right angle here, right, our hypotenuse. In this case, it's 15. So c is 15, and I want to make it squared. Okay. A and b, it could be 10 and 5, so let's go ahead and write that. So we're going to put, x and 5, so it's going to be x squared plus 5 squared. Okay, with this, we're just going to simplify, so x squared remains the same. 5 squared is 25, and 15 squared. 15 multiplied with 15 is 225. Okay. Well, with this, what we really want to do, what we just set up is an algebraic equation. And with this, we would like to solve for this variable x. So we're going to get stuff away by doing the inverses of what we have. So the inverse of adding 25 is subtracting. Okay. And 225 minus 25 is 200. Okay, alright, and with this, I have x squared. We would like to square root both sides. And we're going to have x equal to. And I think this is where we kind of get a roadblock here. Square root of 200. What you want to ask yourself is what number multiplied with itself will give you 200. And it turns out that there isn't an integer that satisfies this. So maybe you'd have to guess and check. Maybe you just have to see which integer do I square gives me closest to this. So just kind of spitballing ideas. What about 10? 10 squared, that gives me 100. Okay, not quite it. 11 squared, that's 121. It turns out the numbers closest to this, just kind of writing out over here, let's do 14 squared. 14 squared is 196. Not quite 200, so let's do 15. Let's see what 15 squared is, and we actually did it over here. It was 225. Okay, so the number that gets me closest to 200, I see that 196 is closest to it. So it looks like how much it'll reach up the wall. It's approximately, I'm going to put two squiggly lines instead of an equation, approximately 14 feet. So with this, it's really close to 14 feet. Not quite exact, but it is a good approximate here. Okay, so it says to the nearest foot. That's why we're approximating. All right, number three. Number three says a cone has a diameter of 8 centimeters and a height of 4 centimeters. Okay, but then it gives us a statement is that if the height is cut in half, then the volume is what? And our choices are, is it half as large, a fourth as large, twice as large, or the same? Okay, so the only way for just me processing this is that I'm going to look at this and actually just find the volume of these two figures. So what I'm going to do is I'm going to separate it into half. Okay, so for a cone, we need the radius and we need the height. Okay, and the formula for the volume of a cone, it's the formula for a cylinder, but just divided by 3. Okay, so for a cylinder, it's pi r squared, which is a circle, multiplied with our height, and divided by 3. Alright, so what we were given is we were actually given the diameter. The diameter, the whole distance away, which is 8. Well, the radius is half that, so the radius would be 4. Okay. The height we're given, that it is also 4. Okay, so let's go ahead and compute the volume according to this. So just writing the formula out. Okay, and inputting what we know. Oops, there should be a 3. So pi r is 4 squared times 4, which is our height, and divided by 3. So all I'm doing is taking my r, inputting where I see it here, my height, and inputting where I see it here. Okay, order of operations indicates that we square our exponent. So 4 squared is 16, and 16 times 4, that's 64. So in our numerator, I'm going to rewrite it as 64 pi divided by 3. Okay, so approximately I could simplify this, but let's just keep it like this. Our volume is 64 pi divided by 3, and this would be centimeters cubed. Okay. Now let's get to the second statement here. It says if the height is cut in half. So now my height is no longer 4, but rather it's 2. Okay, cut in half. So this cylinder, same base, but now it's a little bit shorter here. Okay, so let's see what we would do with this. So similar setup. We're going to divide by 3 and input what we know. So pi r is 4, so the radius is the same, but our height is 2. Okay, and maybe you can see it. So 4 squared, same thing, 16, and 16 times 2 is 32. So I'm going to rewrite this as 32 pi divided by 3. Okay, so just comparing the two, this was my original, 64 pi divided by 3 and 32 pi divided by 3. And clearly we can see that even though these numbers are a little bit odd because they're fractions, we can clearly see that this second one, it's half as large. So our answer for this is 8. Okay, so a lot of work, but noticing your formulas for volume, right? We talked about that a cone is a third of a cylinder, and using that in order to test this statement here. Okay. All right, number 4. Number 4, it gives us 4 sets of numbers, and it's asking us which ones represent a right triangle. Okay, a right triangle meaning that we can test this. We can test this using the Pythagorean theorem. All right, so I'm going to separate this between 4 different sections. Okay, the first one will be number 1, which is 3, 4, and 5. Second one will be 5, 12, and 13. Third, 4, radical 24, and radical 8. And 5, 7, radical 74. And what's awesome with this, when they set up the numbers, the last numbers here, those should be our hypotenuse. And yeah, so it's clearly set up. If we get a true statement, that means it is a right triangle. Okay, so let's just start with the first one. So we're going to have 3 squared plus 4 squared equal to 5 squared. Alright, well this will be 9 plus 16 equal to 25. And 9 plus 16, I believe that's 25. So yep, we get a true statement. Okay, so this is a right triangle. It satisfies the Pythagorean theorem. So with this, we know that 1 is true. Okay, so I know that in contention we have A, B, and C. We can cross out D because it doesn't have a 1 there. Alright, going to number 2. Number 2, we have 5, 12, and 13. So let's go ahead and put this in. So 5 squared plus 12 squared equal to 13 squared. Alright, this is 25 plus 144 equal to 169. Alright, 25 plus 144 is 169. And this is a true statement, so number 2 is correct. Okay, so we have 2 that are right triangles. Okay, let's check out the third. So this will be 4 squared plus, and be careful with this, the way you're going to write it is you might want to write parentheses around this. It is radical 24 squared equal to 8 squared. Alright, 4 squared is 16. Radical 24 squared. We should know that squares undo square roots because they're inverses, so squares undo square roots. So we have 24. That comes out. Okay, this happens every time when you take a square root of or a square of a radical. And 8 squared is 64. Okay, adding the left side, 16 plus 24, I believe, is 38. Oh, sorry, 40. So it is 40 equal to 64. We notice that that's not the same, so 3 is not true. Okay, let's go on to the last one. We're going to write 5 squared plus 7 squared equal to radical 74 squared. Alright, so we're going to get 25 plus 49 equal to, and this simplifies to just be 74. Okay, what is 75 plus 49? Well, 9 plus 5 is 4. We're going to have, carry the 1. And 2 plus 4 is 6, plus 1 is 7. So this is a true statement. So we know that 1, 2, and 4 are true. So with this, we're going to look at our answer choices, and 1, 2, and 4, that is letter C. Okay, that's our answer for this. Alright, moving on to the next one. Next one says, what can be concluded from observing a triangle translated 4 units up, then reflected across the y-axis and rotated 90 degrees, counterclockwise. Okay. To represent our triangle, the fact that we're using a triangle is important here, but I'm just going to use my marker. Okay. And we're going to note what happens with the pre-image to the image. Does it double? Is it get 4 times as big? Is it similar? Or is it congruent? Okay. If I were to have something and I translate it 4 units up, okay, 1, 2, 3, 4. Okay, then I reflect it off the y-axis. Okay, reflect. And then I rotate it. Alright. Did anything happen to this marker? Nope, it's the same thing. It didn't get bigger, it didn't get smaller. All we did was kind of just move it in certain places. So it is the same exact thing. It's the same size and the same shape. So with this, that satisfies the idea of congruence, and D is our answer for number 5. Okay. Alright, going on to the next page. Find the length of AB. Okay, find the length of AB. What I don't want you to do is just count the boxes. That's not what's going to help you here. But what will help you here, and just note that Pythagorean theorem is an important idea here. So what I'm going to do is I'm going to draw 2 lines, just like this, 2 line segments. And with this, we create a right triangle. And just kind of in the back of your mind, we should be thinking of Pythagorean theorem here. Alright, with this, what is this distance, this height here? This happens to be 4. Over here, the width of this triangle is 5. But we want to find this distance, and when we don't know what something is, we put a variable here. So I'm going to put x. Okay, so using the Pythagorean theorem, we're going to set up 4 squared plus 5 squared equal to x squared. Alright, well 4 squared is 16, 5 squared is 25, and x squared remains. 16 plus 25 is 41, equal to x squared. We want to find out what x is, so let's get rid of this square. So we square roots both sides, squares undo square roots. We have x equal to. Square root of 41 does not simplify to be a nice number, but just looking off to our answer choices, we can see that it is D. That is the correct answer for number 6. Alright, going to number 7. What is the distance between 2 coordinates, those coordinates being 5, -2, and 2, -1? Now, the thing is, this is very similar to number 6 in the sense that we want to find the distance between 2 points, right? We have a line segment represented on this graph over here. So what I want to kind of reference to, it's maybe use this method. How about I try to graph these points and then find the distance there? Okay. Alright, so what I'm going to do is I'm just going to go ahead and graph it. So drawing an x and y axis, okay, I'm going to draw it very kind of strategically here. Let me go 5 to the right. So y-axis and x-axis. Let's put some points over here. 1, 2, 3, 4, 5, and that's enough. The first coordinate is 5, negative 2. So that's 5 to the right and 2 down. Right here, that's a good location for it. And 2, negative 1 is the second coordinate. So that's 2 to the right and 1 down. So these are our 2 coordinates. Okay, I want to find this distance here. Okay, so doing what we did from the previous problem, just try to create a right triangle given kind of the grid that we had. So this is a very rough grid here. Let me just draw this vertical line and horizontal line. Okay, what is the distance of this vertical line? It is just 1. We went 1 down, and the vertical line, be very careful, we're going 1, 2, 3 to the right. Okay, and I want to find this distance, which is x. So we're going to set up the Pythagorean theorem again. Okay, so you're going to hear it from me 1,000 times. So we're going to have 1 squared plus 3 squared equal to x squared. Okay, and that x squared is our hypotenuse, so that's why it's over here by itself. 1 squared is 1, 3 squared is 9, equal to x squared. Left side will become 10, and I will square roots both sides, and we're going to have square root of 10 equal to x. Alright, this doesn't simplify, and if I look at my answer choices, square root of 10, yep, right there, letter B is the correct answer for number 7. Alright. And let's go to number 8. Number 8 says a 113 degree angle is rotated 180 degrees clockwise. What is the measure of the angle in the image? So image just meaning what happens after our transformation. Okay. Alright. I want you to imagine if we take a 130 degree angle, let's say maybe it's this, and we rotate it at all, okay, what happens with this angle? If we rotate it, nothing happens. It remains 113 degrees, right? If I were to take this, it's not 113, but let's imagine it is, and I rotate it somewhere else. Okay, I rotate it over here. All right, it does not change size; it remains the same. So not too much thinking. What you should know is that reflection, rotation, and translation. These transformations are all congruence transformations, which means if I were to perform this, we get the same exact thing. Doesn't change anything, same size, same shape. So with this, rotation remains 113 degrees. Okay. Alright. For number 9. Number 9 says, a student dilates the given trapezoid by a ratio of 2 to 1 about the origin. What ordered pair describes the location of D after the dilation? Okay, so with this, after the dilation, so we want to look at coordinate D. D is at the coordinates 3, 3. Okay, we have a scale factor. It says from 2 to 1. Now, is this an enlargement or reduction? Okay, we're saying every 2 units is now 1 unit. Okay, so we're definitely getting smaller here, right? I mean, it looks like we're cutting in half. We're dividing by 2. Okay, so what I'm going to do, we're cutting this coordinate in half. We have to find what is half of 3 and 3. Well, that's 1.5 comma 1.5. And that is D prime. So with this, B is our answer for number 9. Number 10. Number 10, it says if a figure is reflected over the x-axis and then reflected over the y-axis, what one transformation could accomplish the same end resulting figure? Okay, so what I'm going to do is, how about I give you an example here. Okay, so I'm just going to go draw an x and y axis, and let's perform a reflection about the y-axis and then the x-axis. Okay, so let's say we had a triangle like so. I'm just going to draw a right triangle that goes like this. Okay, we're going to reflect it over the x-axis first, so if I were to reflect this over the x-axis, it looks like this, right? Just kind of thinking of that mirror image here, it goes like that. Okay, and from this, I'm going to take that green triangle and now reflect it over the y-axis, which is this vertical line. and that's going to look like this. Okay. All right. So what it's saying, what could I have done with the original shape to get from this black triangle to this red triangle? And the choices are dilation, reflection, translation, and rotation. Okay. Dilation wouldn't help me here because it would just make it either bigger or smaller, and as we can see, it's the same exact shape. Reflection, it actually took us 2 reflections to get this. If we were to reflect over this line, which I'm assuming many students are going to think that we could, it wouldn't quite get us the same shape. Very close it would. It would give me to as a third quadrant. Translation wouldn't work because I'm just taking this triangle and moving it, but it's not. It wouldn't quite get this orientation. Rotation would. Rotation, just kind of imagine that I'm at the origin. I'm just rotating this. All right, and if I were to rotate this all the way around, we would get this this red triangle, and for this, D is our answer for this. Okay. Number 11. Which series of transformations will create a similar figure? So similar figure means same shape, but different size. Okay. All right. For letter A, it's saying rotation and translation. Would this give me something that has the same shape but different size? All right. So what could I do? Let's use this thing. Okay, so we have a teddy bear, whatever this is. If I were to rotate this and then translate it, which is just moving, okay, this is the same exact thing. All right, doesn't change shape, doesn't change size, it's the same exact thing. All right. If for B, it says a reflection and rotation. So reflection meaning it goes like this now, and I rotate it. Okay, same exact thing. I do not have another bear-looking thing. Okay. C, it says reflection then dilation. So reflection. But then dilation, this could either get bigger or smaller, and that's what it means for us to have similar figures. So C is the correct answer here, and that's the only one that would work because of the dilation. Okay. All right, let's go to number 12. Number 12 says the volume of a cylinder is 144 pi inches cubed. The radius is 4 inches, and we want to find the height, right? So let's go ahead. I'm just going to go ahead and give you the diagram of a cylinder. So here we go. Okay. Awesome. Looking at this, we're given that our radius is 4 inches. Okay. Our volume within this is 144 pi, but we don't know our height. Okay. How must this height, or what must the height be for us to equal this? Okay. So let's go ahead and write the volume. It's pi r squared, which is the base of the cylinder, which happens to be a circle. Okay, and pi r squared is actually the area of a circle. So that's the space of this entire circle here. And multiplying with h, all right, h is our height. Well, I like to think of this as we're multiplying a circle times how many circles we have up. Kind of think of balonies, right? If I have a baloney, which is a circle, and multiplying by how many balonies will give us this entire cylinder. All right, so let's go ahead and input what we know. We know the volume. The volume is given to us that it's 144 pi. Okay, I'm going to write pi. We're given the radius, which is 4 inches squared. And we don't know what is our height, so let's go ahead and just write h for that. Okay, solving for this, let's simplify the right-hand side. So I'm going to keep the left-hand side. So 4 squared is 16, so let's rewrite this as 16 pi h. I like to write the number in front of pi here. And if you notice, this is being multiplied to h, so I'm going to undo that, which is dividing. I'm going to divide by both these things together, just to save time. So we're going to have h equal to, pi's undo each other, and I have to figure out how many times can 16 go to 144, and it turns out to be that it's 9 times, because 16 times 9 is 144. Okay, so our height has to be 9 inches, so C is the correct answer for this. Okay. All right, going on to number 13. Number 13, we have kind of an odd shape. It looks like we have an ice cream cone type of figure here. But it says the shape below was made by putting a hemisphere on top of a cone. What is the total volume of the shape? So this hemisphere, let me do the best I can to draw this here. Like this. Oh, pretty good. Okay. So I want to break this up between a cone, which is this bottom portion, and a hemisphere, which is half a sphere. Okay. So let's go ahead and find both of these things. Alright. Alright, so I'm going to go ahead and put hemisphere over here. Okay, that's a horrible drawing at a hemisphere. And over here. Okay. The volume for a sphere, it's 4/3 pi r cubed. Okay, for a cone, remember it's just a cylinder, but divided by 3. Okay. Now, the thing is, for a sphere, it's 4/3 pi r cubed, but for a hemisphere, it's going to be half of that. Okay, the way that we can, what you could do is you could try to find this and divide it by 2, but let's go ahead and make this for half of it. So this will be 2/3 instead. Okay, all I'm doing is just taking that 4 and dividing it by 2, which is 2. Okay, looking at our diagram, so if you're looking at your packet, we have that the diameter is 6, so the radius has to be 3. Okay, so let's put that the radius is 3. We're also given the height of this, so the height may be important here. I'm going to write over here that it's 4. Okay. The only variable that I care about for a hemisphere is the radius. So let's go ahead and write 2/3 pi, our radius is 3, cubed. Okay, so let me rewrite this. Alright, 3 cubed, that means 3 times 3 times 3, which happens to be 27, because 3 times 3 is 9, multiplied with another 3 is 27. Okay, when I need to simplify this here, what I'm going to do is I'm going to multiply this by 2. You can kind of think of this as over 1. So 27 times 2, it is 54 pi divided by 3. And it actually turns out that 3 can go into 54 evenly. It goes into 12 times. So it's 12 pi here. Okay, so this is the volume for the hemisphere. Alright, similarly, we're going to input what we know for this. So we're going to have pi. Our radius is 3, so radius squared. And our height, we're given that it's 4, right? Just writing it over here. And we're going to divide this result by 3. Okay. Alright, let's simplify our numerator. So we're going to have 3 squared. Well, that's 9. 9 times 4, which is 36. So we're going to have 36 pi divided by 3. And 36 divided by 3 is 112 pi. And that's our answer for this. Actually, so, made a mistake. For this one right over here, 3 can go into 54, actually 18 times. Okay, there we go, all fixed. So in order to find the entire shape for this kind of weird shape over here, I'm going to add both of these numbers, 18 pi and 12 pi, and we're going to get that this is 30 pi. So it's 30 pi centimeters cubed. Okay, good. Alright, the next shape. It says a triangle EFG has vertices at E, which is at 5, -2, F is at 2, 0, and G is at 8, -2. Okay, so with this, it says find the coordinates of the image of E after reflection across the y-axis. So we don't care about F, we don't care about G, that doesn't help me here, even though it's part of a triangle. We're only focusing on E. A couple different ways that you could do this. But what I'm going to do is I'm going to graph it. Okay. Alright, and let's graph the coordinate 5, -2. So that's 5 to the right and 2 down. Okay, let me go over here. Alright, let me label my y-axis, my x-axis. And what we're going to do is we're going to reflect E off of the, and it says the y-axis, that's this line. So when I reflect it, I want it to be somewhere over here. Okay. With reflected, we want to look at how far was this away from this line of reflection. It turns out it was 5 away. It was 5 to the right, so now it's 5 to the left. Okay, so this would be E prime, and the coordinate for this is -5, -2. And for this, D is our answer for 14. Okay. Alright, getting on to the next one, number 15. Okay, number 15 is saying in the diagram, we want to find, we know that these two lines are parallel, these two lines intersect, and we're getting certain information that angle B is 70 degrees, angle E is 45, and we want to find what is the measure of angle DCE. So DCE, what is this angle right here? Okay, now this goes into that we're given that this line and this line are parallel. We can use some angle pairs. What I'm going to use is I'm going to use the idea of alternate interior. Meaning if an angle is inside of our parallel lines, it is congruent to the alternate side of what we call a transversal. Transversal is just a line that that intersects two parallel lines. So this angle is congruent with this angle, which is 70 degrees. Okay, so this goes into really looking at a problem and exercising your problem solving and critical thinking. All right, well, we have a triangle here, and I know that the three angles in a triangle equal 180. So what I'm going to do is I'm going to add these two. So 70 plus 45, that is 115. In order to find this one, I'm just going to subtract this result by 180. Okay, well, can't not take away 5 from 0, so we're going to borrow. 10 minus 5 is 5, and 7 minus 1 is 6. So it is 65 degrees, and if I were to add these three angles up, we would get 180. But for DCE, angle DCE, the answer is B. Okay, all right. Next one is similar idea that we're dealing with a triangle, but we're given that measure angle A is equal to an expression, B and C as well. And we want to find what is the measure of angle C. Okay, for me, what would be really helpful is to draw a picture, all right, just so I can kind of visualize this, right? We have a triangle A, B, C. Okay. Now what we should note, like just from the previous problem, is that the angles of a triangle equal 180. Okay, meaning that if I were to take 3x minus 20, 2x plus 40, and 3x plus 24, it equals 180. So I'm going to write that out. Okay, so we know that A plus B plus C is 180 degrees. Okay, so instead of A, I'm going to write what it gave us. A was the expression being 3x minus 20. B was the expression 2x plus 40. And C was the expression 3x plus 24. And all these added up together are 180 degrees. Okay. Now what I'd like to do, I have a bunch of stuff that's happening on to the left hand side. Let's simplify that. Let's figure out what are like terms. So 3x is a like term with 2x and a like term with another 3x. What does that combine to be? So 3x plus 2x plus 3x turns out to be 8x. Okay. All right. Let's figure out like terms with negative 20. It's 40 and 24. All right. Well, negative 20 plus 40 is 20, and 20 plus 24 is 44. Okay. And this is all equal to 180 degrees. All right, and I'm confident that at this part you can see that we're solving for x. So we set this up algebraically, so let's get stuff away from x. I want to figure out what number do I put into here to satisfy this equation. We're going to do that with inverses. So we're going to subtract 44 to both sides. Okay, so we have 80 or 8x equal to, and 144 minus, or 180 minus 44 is 136. If we divide 8 to both sides, we're going to have x equal to 17. Okay, awesome. We found what x is. So we would think that B would be our answer, but let's look at the question. The question said find what is C. I haven't found what is C though. I found what x was. Okay. Well, C says C is equal to 3x plus 24. So I think what I'm going to do with this is just plug this in wherever I see an x. Okay, so let's go ahead and do that. So we're going to have 3 times 17 plus 24. Okay. 3 times 17 is 51 plus 24. All right, and that, well, if I add these numbers together, it is 75. So measure of angle C is 75 degrees. So with this, just plugging it in, it is D for number 16. All right, number 17. Number 17, a bunch of stuff happening here. What I'd like to do is fill out certain information on this triangle before I can make any assumptions of which of these statements are true. Alright, so I know that this measure is 10, this measure is 5, this measure is 13. Okay, it looks like from this triangle to this triangle, right, this, just matching up the sides here, this is 5 and this is 10. It looks like we're multiplying by 2. Okay, so right, I multiply 5 times 2 to get to 10. So using 13, well, to get this side, I multiply by 2, and this should be 26. Okay, so I know that the hypotenuse of AC is 26. All right, now we have a right triangle, and just know Pythagorean theorem. Pythagorean theorem is going to help us. All right, with this, if I were to use a Pythagorean theorem just to save time, I know that DE will be 12. Okay, I could use a Pythagorean theorem here, but let's use our kind of newfound idea that we multiply by 2 to get this triangle. So if I want to find AB, the one that corresponds with it, which is DE, which is 12, multiply that by 2, so this is 24. Okay, let's look at these statements here. Okay, now we're kind of filling out all the information that we need. A says the perimeter of triangle ABC, which is this one, is 29. Well, the perimeter means to add up the sides, and as we can clearly see, it won't equal 29, so that's false. Nope, not even true. Alright, B says AB is 12. Well, AB we found is 24, so nope, not true. C, the area of triangle ABC is 120. Okay, for the area of a triangle, what it is, it's the area of a square, but divided by 2. Okay, our base times our height. Alright, well in this, our base over here is 10, and our height is 24. And we're going to divide that by 2. Well, 10 times 24 is 240. And divided by 2, it is 120. So, C is actually true. That is the area of triangle ABC. And there we go. We don't even have to go to D. We know that this one's false. Okay. Alright, getting on to number 18. Number 18 says, triangle ABC is similar to triangle JKL. And before I get to filling in the information, what helps for me is to draw a picture. Please, when you get to this, draw a picture. It's going to help you visualize it. So labeling the same way, so JKL. Alright, now let's use the information that's giving us. Alright, it says BC is 12. Okay, I'm going to write 12 there. JK is 2.5. And AB is 10. And we want to find what is the measure of KL. So what is this guy here? Okay. Well, we can match up certain sides. AB to JK, we know these sides. This is 10 and this is 2.5. Maybe kind of hard to see, but how do I get from 10 to 2.5? Or maybe from 2.5 to 10? Looking at this, we'd have to divide by 4. Okay. If I take this, maybe think of this as $10 or maybe $100. But if I were to divide this by 4, we would get 2.5, right? How about I think of this as $100? Let me just put a 0 here. Okay. If I were to do that, we move the decimal point 1 over, so it's actually at the end. So if I take 100 divided by 4, it's 25. Okay. If I take 12 and divide it by 4, this is 3. So our answer for this is 3 units, and it is C. Okay. All right, number 19. We're close to the end. All right, number 19 says Kate borrows $360 from her mother and agrees to pay her back the same amount each month without interest. After 5 months, she still owes her mother $280. Choose the linear function that models the amount Kate borrowed her mother or owed her mother each month since she borrowed the money. Okay, we're given 3 or 4 equations. Okay, if you notice, these equations are in slope-intercept form, so y equals mx plus b. Okay, so for this, we should probably know that this is the y-intercept, this is the slope, how much we're moving. But this is what I like to think of it as. This is where we begin, where I start, and this is how much we move, how much we increase or decrease. Okay. Well, the number that's by itself is where we begin, and in this scenario, we started owing, or Kate started owing her mother $360. Okay. So which one says that I owe her $360? It is A and B, so let's knock out C and D. Okay, those say that we start owing her $280. Not quite true. Okay. Now, we gave our mother back some money. We now only owe her $280. Well, how much did we give her back then? So we started owing her this much, and now we only owe her this much. I'm going to find the difference to find out how much we've actually given her, or given back to her. It's only $80. So Kate has given her mother $80. The thing is, in 5 months, if she gives back the same amount every month, how much would she be giving back then? Okay, so what we should probably do is we should probably divide 80 by 5 for the 5 months that we've owed her money. Okay, and we would do this, so just divide 5 by 8, which goes into once, and with the remainder of 3, bring down the 0, and 5 can go into 30 6 times. So it turns out that every month we give her back $16. Okay, so we now owe her less money. Okay, so that's why we see of these choices how much we've given her back. It is B. Okay, that's the correct answer for this. All right, number 20. Number 20, dealing with another Pythagorean theorem problem. They want to make sure you guys know this on the test. So, in this last problem, it says, why is it not possible to make a right triangle using lengths 60 degrees, 60 inches, 40 inches, and 25 inches? Okay, so let's go ahead and put that in the Pythagorean theorem. So of these three that we have, the biggest one is 60. So I should know that that's my hypotenuse. So a squared plus b squared equal to c squared. Let's go ahead and write, let's put 25 squared plus 40 squared equals 60 squared. Okay, and if you were to multiply this out, this isn't true. And in the problem it says that it's not true. So it's saying which one of these representations here should be equivalent to using the Pythagorean theorem. Okay, if you'll notice the format of all these problems, it shows with a combination of 60s and 40s. Let's get that together. Okay, so we know that these are not equal, so I'm going to draw a line through it. So let's get our 40 and 60 together. So I want to get this 40, let's just move it with the 60. Let's just see what should happen. So so this is not equal to. If I were to subtract 40 squared to both sides, right over here, I'm just going to keep those, I'm not going to simplify. Let's just write 60 squared minus 40 squared. Okay, so this says 25 squared does not equal 60 squared minus 40 squared. So which one of these answer choices says that? It is D. It does say it, but kind of in the reverse order. That is equivalent, and we're using Pythagorean theorem for that. Alright, that concludes the first part.